Welcome. Today, we learn about complex numbers. So, what is a complex number? A complex number can be found in the form of a plus bi, where a and b are real numbers, and I is the imaginary number. So, what is I? I is defined as the square root of -1. Then that means I squared is -1. Now we're going to try to tackle some expressions with complex numbers. First, we're going to try the square root of -20. Then we're going to try 3 root -169. You first want to see that -20 is actually the square root of -1 times 20. And since we previously defined that the square root of -1 is I, you can simply remove the square root of -1 and just leave I times the square root of 20. Now you want to put the square root of 20 into simplified radical form, which is 4 root 5. So then you would multiply 4 times I to get 4I root 5. To move on to our next expression, which is 3 root -169, you want to again acknowledge the fact that -169 is -1 times 169, which then you could replace the square root of -1 as I. So then you would have 3 times I times root 169, which is 13, and then you're left with 3 times 13I, which is 39I. Now we're going to move on to adding and subtracting complex numbers. So what you would do here is you would combine like terms. So then you would combine 2 and 4 and 3I and 3I, which would give you 6 plus 6I. And now we're on to equations with complex numbers. And here you have an equation that can only be solved by using the quadratic formula. And then first you want to figure out the values of a, b, and c, which is a is equal to 1, b is equal to -10, and c is equal to 34. You want to then substitute in all those numbers in the quadratic formula, which would then get you eventually to 10 plus or minus the square root of 100 minus 136 over 2, which would then get you 10 plus or minus the square root of -36 over 2. So then you have the square root of -36, which is then the square root of -I times 36, and then you can replace the square root of -1 as I. So then you would have I root 36. So then the square root of 36 is 6, which would then give you plus or minus 6I. So instead of the square root of -36, you would have 10 plus or minus 6I over 2, which is then 5 plus or minus 3I.
So in the equation x squared minus 10x plus 34 equals 0, x is equal to 5 plus or minus 3I. Now while we're on the subject of plus or minus answers, I want to bring up the difference between expressions and equations with complex numbers. So for an expression, if you had the square root of -36, that would become 6I. But for an equation, if you had x equals the square root of -36, x would equal plus or minus 6I. That's very important to remember the difference. The answer to an equation with complex numbers is always going to come in a plus or minus bi format. So you see that in the answer to the above equation, in which 5 is a and 3 is b. And when you see an equation that is a plus bi or a minus bi, the opposite is always implied. So if you just saw, for example, 5 plus 3i, you would know that 5 minus 3i is also implied. This is called the rule of complex conjugates. And some other examples are 7 plus 4i, so if you saw that, you would know that 7 minus 4i would also be a solution. And 29i also implies -29i. Even though you don't see an a value, the a value is equal to 0, and therefore the rule still applies. Again, just remember that this only applies to equations. For example, if you had an expression that was the square root of -36, after evaluating the expression, you would have 6i. You would not have -6i. Okay, so now we are going to be learning about squaring I and I to a power. So as we know, I to the 0 power, or any number to the 0 power equals 1, and any number to the first power equals that number. So I to the 0 power equals 1, and I to the first power equals I. We know that I squared is negative 1 because the definition of I is the square root of negative 1. So as we know, I to the third power equals I times I times I, and I times I is negative 1, so negative 1 times I would equal negative I to the fourth, or I times I times I times I, is equal to I to the third times I to the first, which is equal to negative I times I, which if you look at the math that I've already done out, is equal to 1. As you might be able to see by now, the powers of I follow a pattern, which is 1, I, negative 1, and negative I, and so on. So now we're going to try something a little bit more difficult, which is I to the 441st power. You might be thinking that you're going to be sitting here multiplying I like 441 times, but it's actually a lot simpler than that. So as we know from our exponent properties, I to the 441st is equal to I to the 440th times I to the first power, because when you multiply exponents, they add. And if you don't know that, then there is an exponents video on the channel that you can view right now. We can break I to the 440th down further into I to the fourth power to the power of 110, because I to the fourth is where the pattern of the powers of I starts repeating. And so we know that I to the fourth is equal to 1, so that breaks down to 1 to the 110th power, which is ultimately equal to 1, because 1 to any power is always going to be 1. Again, you can check out the exponents video if you want. Now we are left with I to the 441st power is equal to 1 times I to the first, and as we know, I to the first equals I, so I to the 441st power equals I.